All right, so Math 1, this is EOC Review 5. This is on exponential functions. So we got EOC Review 5, and this is exponential functions. Please make sure that you go back and study your note cards. That's why we're writing them, so that you can go back and study. Let me see, the last note card number that we were on, let's see if I remember, was 25. So this one's 26, okay? So this is note card 26. This note card is going to be on laws of exponents. So we're going to review a little quick refresher on laws of exponents. Okay. All right. Do not forget that when you are multiplying, remember that this right here is the base and this is the exponent. The exponent tells us how many times to multiply the base times itself. So that means that if we have 5 to the third power, we're multiplying 3 times itself 5 times. So that's 3 times 3 times 3 times 3. 1, 2, 3, 4. One more time. 5. To type that in the calculator, we type it as 3 like this, caret key 5. Any questions about that? 3 caret key 5. And then, of course, we get 243. If we want to simplify it completely. In most cases, they will have you just leave it in exponent form. So that is going to be 3 caret key 5, just like this. The caret key is right here. All right. If you are multiplying, when you're multiplying like basis, so we're going to write multiply like basis. When you multiply like basis, you add the exponents. So that looks like this. I'll show you. Slide this up just a little bit. That looks like this. You may have 4 to the 7th power times, you see how the bases are the same? 4 to the 5th power. That's the same as saying 4 is being multiplied 7 times, and then 4 is being multiplied 5 times. So when you're multiplying exponents and they have the same base, all you have to do is add the exponents. So that's going to be 7 plus 5. What's 7 plus 5? 12. So your answer is going to be 4 to the 12th power. Any questions about that? Now we have dividing. We're going to have dividing like basis. When you divide like basis, you're going to subtract the exponents. You subtract exponents. So let's suppose you have 8 to the ninth power divided by 8 to the second power. Okay, when you do this, yes, baby. Yes, it's on the board. So when you do this, it's top exponent minus bottom exponent. So that's 9 minus the 2. What's 9 minus 2? So this is going to be 8 to the 7th power. Okay. And I'll pause for the calls and give you a chance to catch up. All right. Anybody still writing? Okay. Let me know when you finish, babe. Okay. All right. So now we're going to do a power raised to another power, or exponent raised to another exponent. So it's power of a power. That's an exponent raised to another exponent. When you have that, you multiply the exponents. So let's suppose that we have 7 to the 4th power, and we're raising that to the 5th. So this is saying that you're going to be multiplying 7 to the 4th power 5 times. So the shortcut way of doing that is to say 4 times 5. What's 4 times 5?
20.
So it's 7 to the 20th power. I'm going to pause for the calls. Look at the differences between them so you can see when to do what. So, great question is, if they're different, then you can't do any of these, okay? You just have to do it separately, okay? Use order of operations. If it doesn't look like this, if the bases aren't alike, then you can't do any of these steps, okay? You just have to do order of operations. Okay, so we got zero exponent. When the exponent is 0, the answer is automatically just 1. So we have 7 to the 0 power is 1. Even the letter A to the 0 power, doesn't matter what A is, the answer is going to be 1. Any number raised to the 0 power is going to be 1. Any questions? -2 to the to the 0 power, this is going to be -1. Okay. But if I have it as this, -2 to the 0 power, this is going to be +1. There's a difference there. Okay. This is doing 2 to the 0 power, which is 1, and then multiplying the negative. This is doing -2 to the 0 power, which is going to be just 1. So there's a difference between the two. Any questions? Turn over on the back so we can do negative exponents. When you have yes, baby. Say again. I'm sorry. I couldn't hear you. Oh, okay. Let me know when you finish, babe. I'll pause. All right, here we go. Negative exponent. Remember, when you are writing as a negative exponent, you write this as a division problem. So if it's negative and it's on the top of a fraction, to make it positive, you move it down to the bottom, and vice versa. So if you have what number haven't I used yet? 6. Okay. If you have 6 to the -5th power, this is the same. You can't leave it like this. You have to write it as a fraction. 1, and you bring this down to the bottom as now a +5. So bring it down to the bottom to make it a positive. If it's the other way around, where you have 1 on the top and it's 4 to a -3, you bring it to the top to make it positive. So now it's 4 to the +3 over 1, but the answer is still going to be 4 to the +3. Okay. Remember, if you have 3a to the -7 and you have b to the -2, okay, to make those positive, to make this positive, bring it down to the bottom. To make this positive, bring it to the top. So 3 stays where it is. B is going to come up to the top and now +2. A is going to go down to the bottom, now making that a +7. So in order to make it a positive exponent, if it's on the top, bring it to the bottom. If it's on the bottom, bring it to the top. That's what makes it a positive exponent. I'm pause for the calls. All right, see if you can do this. We'll pause for the calls and see if you can do that. All right, so on the top, what are you going to do to get, this is going to be 4 to what power? 7, because you add the exponents together, so that's 4 to the 7. 4 is being multiplied 5 here and 2 here. 5 plus 2 is 7. On the bottom, you get 4 to the what power here? 12. Power of a power, you multiply. So you're going to say 6 times 2 is 12. Now it's division. What are you going to do with the exponents here? Top exponent minus bottom exponent. So what does that give you? 4 to the negative fifth power. You can't keep it as a negative exponent. So how do you write your answer here? Very good. Okay, pause for the calls, give you a chance to write. All right, now we got fraction exponents. This is card 27. EOC review 5. Exponential functions. This is fraction exponents. So here you have your regular base. Let's use 5. And let's use 2/3. The top part of this fraction is going to be the exponent, and the denominator of the of the fraction, is going to be the root. So when we write this as we have 5 to the second. Well, sorry. I'm going to rewrite it. We have 5. Remember, this is exponent. So 5 exponent is 2. And the 3 is the root. So this is to the third root. This is how you write this answer. Top number is exponent. Bottom number is root. And you put the root number here. If it's square root, you don't have to put 2. You just leave it as square root. But if it's any other number other than 2, you got to put the root number there. So let's try this one. Let's do 6. Let's do 4/7. See if you can write that on your own. Pause for the calls. All right. So how would we write this? We write 6 to what power?
4.
The 4th power. And what root is this?
7.
The 7th root. Okay. Let's try one more. Any questions? Raise your hand. Let's try another one. Let's do 2 to the 1/2. See if you can do that one. All right, what's this going to be? 2 to the what power? First power. It's to the first power. Top number is the exponent. And then to the what root? Second, square root. You don't have to put 2 for square root. It's automatically second root because there's no such thing as first root. Any questions? Is there anyone that's lost? Okay. 28th card. EOC review 5. I'm going to abbreviate exponential functions. This is definition. An exponential function is going to be a function that graphs a curved line. Oops. Yes, baby. Equations or functions that graph curved lines. It's either going to be a curve going up or a curve going down. Semicolon. Because it increases or decreases by percent or common ratio. And remember, the letter for common ratio is B. Pause for the cause. Semicolon. There are also geometric sequences. It is also a geometric sequence. Which means you're multiplying to get to the next number. Multiplying or dividing to get to the next number. But you always write it in terms of multiplication. So if you're dividing by 2 to get to the next number, you're really multiplying by a half. Your common ratio is going to be a half. If you're dividing by 3 to get to the next number, you're really multiplying by a third. You always write it in terms of multiplication. All right, let's look at this pattern. Let's look at this pattern here. We have 6, 18, 54, 162, and 486. We're going to write the equation. The standard form for an exponential function is y is equal to a times b to the x power, where your a is your starting amount, your b is your common ratio. I'm going to pause for a cause to give you a chance to write. This is a geometric sequence because you are multiplying to get to the next number. What number are you multiplying to get, using to multiply to get to the next number?
3.
You're using 3. Yes, you're going to multiply by 3 to get to the next number. So our B here, our common ratio is 3. Now we need to figure out what A is. A is the starting amount. This is not the starting amount. This is automatically the first number. This is the second, the third, the fourth, and the fifth. Unless they tell you it's the starting, automatically assume it's the first number. So you got to work backwards. What was the number before? What's this number right here? That number is 2. Okay. Divide. If you multiply by 2 to get to the next number, divide to go backwards. So your starting number is 2. How would I then write that as an equation?
2 times 3x.
Y equals, somebody said 2 times what?
3x.
3
X.
to the x power. This is my equation. Anytime x is an exponent, this is an exponential function. Any questions? All right, let's write the different formulas on the back of the card. Exponential growth. Yes, exponential. What's the formula for exponential growth? What's the formula for exponential growth? What is the formula for exponential growth? Y equals C. Nope.
Y equals C for C 1 plus P.
1 plus what? R. What else? To the x power. Okay. So Y, the total amount, is equal to C, the starting amount, parentheses 1 plus R to the x or t power, where this is the final amount or total. The C is the starting amount or your y-intercept. 1 is 100%. The R is the rate written as a decimal. or percent written as a decimal. I better say percent. Okay. That's exponential growth.
What did Y say?
Total. Come on, child. Exponential decay. What is exponential decay? I heard the Y. That's all I heard you say.
Y is received with Q1 minus R transfer.
Very good. And the letters mean the same. Compound interest. This is when interest is being charged more than one time in a year. Okay. So you'll see something like compounded. What's compounded quarterly? That means n is equal to what?
4.
4. That's quarterly. What about monthly? N is equal to 12. What about biannually? 2. N is equal to 2. What about semi-annually?
2.
That is also 2. I think that's it. So what's the formula? A is equal to
P parentheses
P.
1 plus R divided by A, which is only 2 powers.
Excellent job. Okay, so the starting amount, please make sure that you study. Guys, you gotta look over this stuff. I've been writing it. You need to study. That's why we have note cards. That's why you have a notebook. All of this stuff is also in the notebook, but as you can see, we don't go back and look at our notebook. So this is why we're writing it on note cards. Do you understand? So again, P is the starting amount, N is the compounded amount, R is the same as this, the percent written as a decimal, and T is the time. Don't forget that this time is the years. Please convert to years. If they give you months, divide by 12. It's always going to be years. So we got decay. Another word for decay is depreciation. Another word for growth is appreciation. Okay. Any questions? Finding percent increase, decrease is next. So we're 29. EOC review 5, exponential functions. This is finding percent increase or decrease of an exponential function. This is one of the easiest things to do, but this is the most missed question. Because we think we can just look at an exponential function and instead of using the formula, we just look at it and write down what we think. And that answer is always going to be down there because they know that's what you do. Please make sure that you pay close attention to how to do this because you know this is going to be on there. All right, how do you know if it's exponential growth or decay? Exponential growth is when your B is greater than 1. Exponential decay is when your B is what? less than 1. Please make sure you're right. Sorry. All right, so listen, if you're finding the percent increase, you're using the formula is B is equal to 1 plus R. That's the formula for percent increase. Please, Lord have mercy. Please make sure that you don't just look at the equation to see if it's increase, see what the percent is. You cannot just look at it. You need to substitute and solve. The formula for finding the percent decrease is what? These. So let's do this one. So I have an equation. Y is equal to 2 times 3 to the x power. This is exponential growth because B is greater than 1. Any questions about how I know that this is exponential growth? How do I know by looking at this equation that this equation is exponential growth? Because B is greater than 1. This is B. Okay? So I'm going to use this formula. I'm going to rewrite it. Okay? I got B is equal to 1 plus R. I'm going to substitute 3 in the place of B because this is A, obviously, and this is B. So I'm going to replace B with 3. So this is 3. So I can find the percent that it's increasing by. Okay? Sit up, please. Say again, babe. I'm sorry. Got it?
So it's whichever is attached to the x.
You got it? Okay. All right, so now how do you solve for R? How do you get R by itself?
-1.
-1 on both sides. What's 3 minus 1? So R is equal to 2. How do you write 2 as a percent? I locate the decimal. How many times do I move the decimal? 2 times. 1, 2. So this is 200% increase. Any questions? Raise your hand if you're still writing. Okay, I'm going to pause. All right, so let's look at the other. Y is equal to, let's start this time with 7 times 0.82 to the x power. How do I know that this is exponential decay? Because B is less than 1. Do you see how B is less than 1? That's why this is exponential decay. So I'm going to rewrite the formula. I know that this is A and this is my B. This is my starting amount, and I'm going to multiply this number to get the next number, okay? This is my common ratio. So in order to figure out my percent of decrease, I use the formula B is equal to 1 minus R. I can't just look at it. I don't say, and answer choice down there is going to be 82%. It is not 82%. Okay? So we're going to substitute B, this is B, in the place, 80.82 in the place of B is what I meant to say, sorry. So now what am I going to do to solve for R? -1 on both sides. So this is going to be negative point what? Negative point, say again? 18. Bring down the negative R. How do I get rid of the negative? Divide both sides by -1. And so that's going to give me R is equal to 0.18. All right, so now what do I do to find the percent? Move the decimal how many times? 2. So what percent decrease is this going to be? 18% decrease. And pause for the cost. Please don't get these types of questions wrong by just thinking you could just look at it and tell the answer. You have to use either B is equal to 1 plus R or B is equal to 1 minus R. Exponential function. I'm abbreviating exponential function. This is card number what? 30. And this one is on finding the nth term of a geometric sequence. A geometric sequence is when you multiply to get to the next number. It is an exponential function. So geometric sequence, multiply to get to the next number. And it looks like it can be division, but you write it in terms of multiplication. So if you're dividing by 2, then really what you say is that you're multiplying by a half. The formula is A sub n is equal to the first number in the list, the A sub 1, times the common ratio n minus 1. Okay. So n is the term that you're looking for. So if you're looking for the 10th number in the list, then n is going to be 10. You're replacing n with 10. A sub 1 is the first number in the list. If they say A sub 7, it's the 7th number in the list. If it says A sub 0, that's the starting number. But this is saying A sub 1. This is the first number in list. Your R is your common ratio. It's the number that's being multiplied to get the next number. And again, your N is the term that you're looking for. So if you're looking for the 10th number in the list, then N is equal to 10. All right. Suppose we have 14, negative 28, 56, dot, dot, dot. And they want you to find A sub 12. All right, so what number are we looking for? What's our N? What's our N? 12. Our N is 12. We're looking for the 12th number in the list. What's the A sub 1? What's the first number in the list? 14. This is our first number. And what's our common ratio? What are we multiplying to get to the next number?
-2.
We're multiplying -2. Rewrite the formula. So you're looking for the 12th number. The first number is 14 times a -2. And we're looking for 12. What's 12 minus 1? 11. So we're going to replace 12 minus 1 with 11. Are you growling? You sound like you was growling. Rawr. You sure you wasn't growling?
I promise.
Okay, it's all right. Don't growl at us, though.
Some people are like that, but I'm not like that.
Okay. Thank God you're not growling at us.
Just laugh. You should I know a few people that would though.
I'm sure. Me too, actually. All right, here we go. Let's type this in. 14 times -2 to the 11th power. 14 times, in parentheses, put -2, caret key 11. Please don't forget to type it in this way. James, sit up. And so what's your answer there? -28,672. There you go. This is the 12th number in the list. All right. That's the end of the cards.